Some key formulas we will be working with are the Pythagorean theorem, the distance formula, and the midpoint formula. The Pythagorean theorem tells us that if a triangle has a right angle and we wanted to make a square on each of the three sides, then the biggest square has the exact same area as the other two squares put together. Where does this come from? Well, in this case, we have a side length of 4, and so we've created the area of the square by it of 16 by squaring it, 4 squared. And here we have a side length of 3. 3 squared is 9. And then our hypotenuse then happens to be 5, and 5 squared is 25. So we see then that this Pythagorean theorem tells us that a squared plus b squared equals c squared. This comes in handy in multiple instances. For example, let's say we're working with an isosceles triangle, and we want to find the area of this triangle. We would recognize then that if this was an isosceles triangle, side AB is 13, side AC then, as an isosceles triangle, could also be 13 centimeters. And we have the altitude, which is the height of this triangle, creating a perpendicular bisector, or bisecting this into two triangles. Well, what I know then is if this entire base of the triangle is 10 centimeters, then this base of the triangle is 5 centimeters. So what I need to know in order to find the area of a triangle, which is 1/2 the base times the height, is what is this height? Well, we have created a right triangle out of this, where I know that one leg, A here, is 5 centimeters. The other leg, B, we do not know, and C, our hypotenuse, is 13 centimeters. So using Pythagorean's theorem, I know that 5 squared plus B squared equals our hypotenuse squared, or 13 squared, meaning 25 plus B squared equals 169. Subtracting 25 from both sides, B squared equals 144. So B must equal 12 centimeters. Now that I've found the height of this triangle, I can use my area formula to say that the area equals 1/2. The entire base of this triangle is 10 centimeters times our height of 12 centimeters. Or my total area then of this triangle is 60 centimeters squared. Pythagorean theorem and right triangles can help us when we're trying to use the distance formula. Let's say we were trying to find the distance between 2 points, x1, y1, and x2, y2. We could create a right triangle using those points and label the sides A, B, and we'll leave D for distance. Well, using Pythagorean theorem then, I need to know what is the distance or the measurement of side A. Well, side A would be our x2 minus our x1. Then, considering this in Pythagorean's theorem as a squared, you can see we have x2 minus x1 quantity squared. Likewise then, the height of this triangle would be considered y2 minus y1. Or our b squared side is y2 minus y1 squared. All of this would equal our distance squared. So by taking the square root of that entire thing, we now have our distance formula. Putting this into practice then, we can find the distance between the points -2, 5 and 4, -3. Again, I can consider this as a right triangle and create my distance formula, where first I'm looking for the distance of this side A by taking x2 minus x1. So, labeling my points x1, y1, and x2, y2, I see that first I would take my distance, I'm going to start by squaring that, equals 4 minus a negative 2 quantity squared. Adding to that then, the difference between my y variables, negative 3 minus 5 quantity squared. So my distance squared right now equals 6 squared plus a negative 8 squared, or my distance squared equals 36 plus 64, which is 100. So if my distance squared equals 100, by taking the square root on both sides, I see that my distance equals 10. And this allows us to see the mathematics. Let's say we want to find the midpoint between these 2 points, negative 2, 5, and 4, 3. We're trying to find the point that is halfway in between those 2 points. So in essence, what we'll be doing is averaging the x values and y values. Our formula then looks like an average, where we average x1 plus x2 and divide that by 2. And the y value is y1 plus y2 divided by 2. Looking at this then, we have our x1 plus our x2 divided by 2, and our y1 plus our y2 divided by 2. Negative 2 plus 4 equals 2. 2 divided by 2 is 1. 5 plus negative 3 is also 2. 2 divided by 2 is 1. So our midpoint then is 1, 1.